I'm Anil Kumar, and in this video I'll explain what is Euclid's division lemma and how it is applied to find HCF or highest common factor of any two numbers, right? So we'll take up example to find highest common factor between 45 and 75 using Euclid's division lemma. But to start with, let's understand what it is. So we're talking about numbers in the set of real numbers, right? So we're talking about real numbers. So all the numbers which I am going to consider will belong to the set of real numbers, right? Now, if I divide, let me begin by writing the statement and then we'll elaborate on it. So we normally write this in the form of A equals to B times quotient Q plus a remainder. The terms here are relating to division, right? So it's kind of, this word is for quotient and R is for remainder, right? So the idea is that if you do long division, right? So if you do long division, let us say, and if you are dividing one number by the other, so A is a bigger number, A gets into this position, and you're dividing by B, then you get something here which we treat as quotient, right? So let me write down in a different ink. Okay. So when you do this division, we get some quotient here, right? And if you follow this process, you get some remainder at the end. Correct. So this is what we call as quotient. This is what the quotient is. The term here is called a divisor. Let me write down divisor. This is called dividend. And that is the remainder. Okay, remainder R. Is that okay? So that is what the statement is. So I can write A as product of divisor and quotient plus the remainder, right? That's the division statement. To give you an example, for example, let's take a very simple example. If I divide a number 12, let me take number 13, by 5, then 5 times 2 is 10, and we get a remainder of 3, correct? We get a remainder of 3. So I could always write 13 as equal to 5 times 2 plus 3, the remainder 3. Is that clear to you? Correct? Plus 3. What you notice here is that if I divide 14, I get remainder as 4. If I divide 15, I get remainder 0. So what is the maximum remainder? Maximum remainder is going to be less than the divisor, correct? Or minimum will be 0, right? So we complete this Euclid's division by saying that R, the remainder, is from 0, including 0, to the value B, right? The divisor B. And since B could be positive or negative, it could be negative also at times. Let me write because absolute value. Let's be very clear about it. Right? So if I write, for example, 5 times 3, 15, I get minus 2. Even then the equation works. You understand? So sometimes we could do that. And to take care of that, we write like this, because this definition can be extended to many other applications, correct? That's the reason why we are writing this. But for the moment, just forget about absolute sign here if that is creating a problem, right? Okay. But I think you got it. If I do 5 times 3, I get 15, and the remainder is minus 2, right? And the equation still works. Correct? Okay. So I think you got an idea. So when you do this kind of long division in short form, we call this also as a division statement. You could write 13 as product of divisor and quotient plus the remainder, right? So that is the whole idea. Now we'll use this particular application for finding highest common factor. So what we do here is, I'll just show you the ways we do it, ways we write it using Euclid's division. So of course you will have to divide the bigger number. So 75 becomes the dividend, right? And the divisor is 45. 45 times 1 is 45, and then you could take away, and what you get here is the remainder, which is 30, right? Then you can repeatedly divide 45 by 30 now. So the divisor becomes the dividend and the remainder becomes the divisor. So they kind of switch the positions. So we could now again complete this process, rather continue this process till we get a remainder of 0 to find highest common factor. So 45 is now being divided by 30. So one time we get 15 as a remainder. We'll again repeat this process. The divisor 30 now becomes the dividend, and the remainder 15 becomes the divisor, right? Do you see how it switches? And 15 times 2 is 30. At this stage, you do get a remainder, which is 0. When you get remainder as 0, it means that 15 is a factor of both these numbers. Rather, it's the highest common factor of 45 and 75, correct? So from this division, I should say Euclid's division lemma, if R is 0, then B is a factor of A, correct? B is a factor of A for R is 0, correct? Now here what we observe, that 15 is factor of both 45 and 75, rather it is the highest common factor. So we say highest common factor for the numbers 45 and 75 is 15. The divisor which gives a remainder 0. Is it okay? Now let me rewrite all these statements in the form of Euclid's division. So we could say that 75, look here, 75 is equal to 45 times 1, right? So it is 45 times 1, which is the quotient, plus the remainder, which is 30. And the next time when we divide it, we say that 45 is equal to 30 times 1, right? 30 times 1 plus the remainder, which is 15. And then at this stage, we are saying that 30 is equals to 15 times 2 plus the remainder, which is 0. So in this process, when we are trying to find the highest common factor, what we observe here is that the divisor, which was 45 in the first case, becomes the dividend, right? So the divisor becomes the dividend, and the remainder becomes the divisor. Do you see that? The remainder becomes the divisor. Divisor becomes the dividend, remainder becomes the divider. Until the remainder is 0, Once the remainder is 0, then the quotient, which in our case is 15, becomes the highest common factor. Do you see that? So that is how we kind of get the highest common factor using Euclid's division lemma. So I hope the steps are absolutely clear. In the following videos, I will quickly go through this long division without explaining all this and give you a link for this explanation so that you can always refer to it. Now, based on Euclid's division lemma, we'll have few application questions in this list of videos. I hope that really helps you. Feel free to post your comments, share my videos, and if you like, that'd be great. Thank you and all the best.